next on my tiny bench is this Yamaha CA-600 integrated amplifier. It comes to us with a cut cord, so there's no telling what all might be wrong. I also noticed all of the fuses have been removed. So, like I say, I'm not sure what all might be wrong. It is quite dirty though, and I'll show you that in the next shot from overhead. Back with the overhead shot as promised of the Yamaha CA-600 integrated amp. Nice unit from 1976 or so. You can see there's a nice layer of dirt, and I'm not sure there's something spilled on it or if that's something under this little panel that's seeping up. We'll know soon enough. And I mentioned earlier, these fuses are removed, these fuses are removed, this fuse is removed, and the cord has been cut. So, we'll have to dig into that more. I think before we put the new cord on, we'll remove the front panel, make sure that stays safe, and probably remove this panel, see what's going on under that, and maybe fold down the front assembly and just take a look, see if there's any giveaway signs about why that cord may have been cut to start with. More in a bit. Back on the tiny bench, my tiny bench with the Yamaha CA-600. I pulled off this panel, pulled the front panel off, got it safely stored away. I pulled the protection panel that's here and just exposed the rest of the unit. Took a quick look around. Nothing really stands out as catastrophic. I don't see any major burnt areas. So, all good so far. I mean, it's dirty, don't get me wrong. But the next thing I'll do is I will tilt it on the side, transformer down, and give it an isopropyl bath, light brushing, and we'll see how that cleans up. Usually that takes 2 or 3 times through it, and sometimes cleaning it is sufficient to reveal certain defects. So that's what I will do next. As I say, I'm gonna have to round up a cord and put a replacement cord on it sometime soon, but I'd like to get it cleaned first. More in a bit. Back on my tiny bench, just doing a brief handheld of this Yamaha CA-600. I just want to show that the cleanup is underway, and still got a ways to go, but I think you can see the progress that's already been made. Just the dirt coming off of there was ridiculous. So these power boards attached to the heatsink, and then maybe you can see these power transistors feed through the heatsink and make connection into the power board. That whole carriage comes off with just these 2 screws. So at some point I'll pull those off and clean the chassis underneath the carriage here, and the same thing for the other channel there. I think that's it for now. Got to let some of this alcohol drip on down, and more later. Thank you. Just a brief update. We are working on the Yamaha CA-600 on my tiny bench. In the process of installing the new power cord, got it secured. Don't have it soldered in yet. When I unbuttoned the unit, folded the rear panel back, I noticed that the top receptacle had broken, I'll call them wings. You see here, they're what are used to hold the receptacle firmly to the chassis. I did notice that this one, the one that had the broken wings, is a little bit different than the other three. And the way it was wired in, I suspect that this was done after the fact. I think you can see that, come on, focus, that they just kind of shattered over time. Unfortunately, the combined pieces from both sides is too small to glue it back together. So what I've done is I've ordered a replacement from eBay from a Yamaha integrated amp that's a little bigger than this, but the same era. I'm hopeful that it will fit. Also notice that the fuse wire that would have led over to here had been broken at some point as well. So just those little things take a little time. And the seller of that receptacle is on vacation for another week or so, or at least out of commission for another week or so. So what I may do is I may move forward with installing the new cord, getting it soldered in, and then running this fuse line over to one of the other receptacles, and then just add the other one when it gets here in a week or 10 days. And that will give me the ability to get some power going and see how the unit responds on the dim bulb tester and with Variac. I think you can see that the unit cleaned up pretty nicely. It's still got a little chassis work to do, but the transformer looks a lot better. Caps look a lot better. It's not a bulge, that's just the reflection, but I'll still be checking them for ESR and such. And I think that's about it for now. More later. Back with the Yamaha CA-600 integrated amplifier. Recall that I said what I was going to try to do next was see if the amp would be able to make bias. What we have discovered is that the right side makes bias fine, but the left side, whenever we connect a meter to the test points, test point 1 and test point 2, which is what you connect to check bias, it blows both fuses on the board. So we're going to have to dig in a bit, try and figure out what the connection is between loading those test points and blowing the fuses. See if we can take a quick look at the test points. I'm guessing the test points are on either side of the emitter resistors on the output transistor. Let's see. Test point, test point. Yep. It's a 0.47. So if connecting this and this to a meter, that additional load in a meter with a high input impedance must be something in this portion of the circuit, possibly one or both of these output transistors. I'm not going to put power back on for a while. Got to get to the bottom of why it's blowing those fuses. Don't want to just burn through fuses and run the risk of something else blowing up. First thing I'll do is pull this and just do a physical, pull this being the power amp board, the one that's blowing the fuses. Just do a physical inspection, visual inspection, see if anything jumps out. More later. Thank you. We are back with the Yamaha CA-600 integrated amp on my tiny bench. I earlier finished recording this lovely clip of my troubleshooting process. I brought the amp up in the dim bulb with the variac and monitored the plus and minus 32 volt rails. I also took a look at the 50 volt rail, brought the amp up very slowly. I don't know when it had been started last, and just wanted to have an opportunity to reform the capacitors. And just in case something was going to be wrong, if there's going to be a short or something that might cause some problems, I'd be able to shut it down quickly at a relatively low voltage, not create too much damage. I was able to successfully bring up the variac to 120 volts. I then realized that I had my plus and minus power rail for the power amp, and I had my plus 50 volt for the other circuits, and I decided I would go on mains power and bypass the dim bulb and try to get the DC offset set and bias set. Right channel worked great, worked like a champ, followed the instructions, and it performed exactly as you would expect. Bias was right where it should be. Went to the left channel, DC offset was fine. I went to connect the meter, just the meter now, between the two test points. Make sure I got a good picture there. Between the two test points. And when I connected the meter, both of these fuses blew. First time through, naturally I thought I must have nicked something. Even though I was pretty confident that I had not. Turned the unit off entirely, replaced the fuses, clipped on the test points, turned it on, blew the fuses again. I knew that something was wrong, and I surmised that it was most likely something in this output provision or portion. Could have been anything technically, but I just had a feeling it was here. I pulled this board out. This is the power amp board that we're looking at here. Pulled the power transistors, and sure enough, 613 measured a short with the meter in diode mode. Kind of an interesting aside. I mentioned this before, but I do tend to use one of these all-purpose testers. And when I tested the PNP transistor of the pair, tested fine on here. When I tested the NPN, the tester would go into self-test mode. And I couldn't figure it out. It happened again and again. I replaced the battery, I checked the contacts, made sure that my leads were in properly. So I was convinced that, my 2-year-old tester was probably bad. I'd probably worn it out. So I ordered another one. Cute little thing, rechargeable, less than 20 bucks, nice colored screen. Did the same thing. Every time I would try to test the NPN, it would say self-test in progress. Well, apparently, when you short the leads on this mini testers, they go into a self-test mode. I had no idea, and that's what was happening. So because the NPN transistor, power transistor, was shorted, the tester thought I was shorting the probes, therefore wanting it to enter into self-test mode. Trials and tribulations, eh? So anyway, the NPN version here was bad. So it seemed like I should test the rest of the surrounding circuitry. And that's where we are today. So having determined that was short, I thought I would test the surrounding transistors. As I mentioned earlier, the PNP was fine. So what I'm going to do now is check these other 6 transistors. And board layout shows me that one, 2, 3, 4, 5, 6. Okay, back on my tiny bench with this Yamaha CA-600. Recall that we have a blown power transistor. Two SD371. No volts. No volts. We'll just put it on ohms direct. We look from base to emitter. Two ohms. Base to collector. Less than 1 ohm. Obviously bad. So in conjunction with that, I wanted to test the other transistors on the board. 1, 2, 3, 4, 5, 6. Start with this one. The board itself tells us that's the base, that's the emitter, so the middle one must be the collector. I forget if this one's PNP or NPN, but we'll start. So this would be base to collector. Well, it kind of looks like we might have a problem with that transistor. Everything suggests that this leg here, oh, maybe I was on the wrong leg, that this leg here is the base. No. That looks like a, well, a little high for a junction. Really high. I think I'm going to have to test that one out of circuit. Just looking a little weird. Let's just see. The markings on here suggest ECB. So this is the base. Well, maybe it would help if I put it on diode. Let's start over. That looks like a junction. It could be a junction, but it looks a little high. We'll test that one out of circuit like we were saying earlier. This is 601 and 603, PNP. Oh. That's the junction. That's the junction. 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 So at least those two are not shorted. .605, 601, 603. Try this one. Not sure which one's 605 and which one's 607. Board's not really marked. Well, let's see. Does it identify which one's the base at least? Looks like the middle is the base. So, that looks like a junction. That looks like a junction. So that must be NPN. I think that's 607. Okay. Now we'll look up here. Looks like that's the emitter. And that's the base. So if that's the base, that's a junction, and that's a junction. Junction, junction. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. We tested 1, 2, 3, 4, 5, 6. Let's go back and take a look at this one. Yeah, there's no question the base is on the end here. And I believe this is a PNP. So if we go from there to there, we're looking for a junction. Oh, excuse me, it's an NPN. Looking at wrong note. That looks like a junction. And that looks like a junction. So I think that one's going to be fine. I think that means all of the transistors check fine. So it would look like when the power transistor went, it didn't take any of its sister transistors with it. Another thing I want to check real quick are these 0.47 ohm emitter resistors. .5. This meter's not calibrated, so I think I've just got a bad connection there. Let me try this from the other side. And 0.5. So I think that means the emitter resistors are also fine. We do have a power transistor on order. Do not have it currently in stock. I did check these capacitors earlier. This one tests fine. These three technically are within spec. They're testing a little high, so I think I'm going to change them on both boards since I've already got it torn apart, and you know, replacement capacitors are pretty cheap. These are 85 degrees. I think let's change them to 105s. This is a non-polar, and like I say, it checks spot on with specs. So I think we'll leave it in place. And more later. We're back with the Yamaha CA-600. Finished checking the remainder of the transistors. I wanted to just quickly show the one transistor that we're determining is going to be okay. If I can get these leads to stay in place, that is. And 1, 2, 3. So the red is the base, 2 is the emitter, 3 is the collector. Red, green, black. The mnemonic I always use is read good books. Red, green, black, 1, 2, 3. And when looking at the bottom of a TO3 style transistor, I always think of Becky, B-E-C, with the short side up, base for B, or B for base, E for emitter, and then collector, B-E-C, Becky. And let me hit that again. Sort of. You see the gain is about 40. Voltage across the base, 0.5. And the collector current, 6.2 milliamps. So that is a good transistor. Obviously the gain is lower because it is a power transistor. And that's one of the characteristics of power transistors. I really just wanted to show that that one was still good. I also wanted to point out that I'm going to try something and use this sill pad this time. Traditionally, I would use mica and thermal grease, but I just think that's going to look so much nicer installed, and will certainly have sufficient thermal characteristics, I believe. Gives you a rough idea of what it'll look like. After we get it up and running, we'll try it. We'll run the heat gun on it, the IR thermometer on it, and get a sense of how that transfer looks. Is the heat that I'm measuring here roughly the same as here? As long as it is, I'm going to stick with the sill pads. I had some for a while. I've just always been a little reluctant to use them because I'm a thermal grease kind of guy from way back when. But like I said, I'm looking forward to giving this a shot. More later. Back on my tiny bench with the Yamaha CA-600. The last video I'd mentioned, or last clip, I'd mentioned that we'd be replacing 3 capacitors on each of the power amp boards, and in fact I did. The ones I pulled out were Nichicon, good brand. These are 85 degree. That's not the reason I pulled them though. You notice this is a 220 and it's up at 251 now. So similarly, the other 2 that I pulled were higher than rated. I've noticed in the past that when capacitance starts to increase from the stated value, usually that's an indication that the capacitor may be going bad. And I just didn't want to risk it. I had these nice Panasonics on hand. They're 105. So I put the 220 and the 100, kept the same values. Replaced the Nichicon 85s with these Panasonic 105s. There was also a 1 micro Nichicon 85. Cute little thing. But at 1 micro farads, I went ahead, took a look at where it was in the circuit, and it's in the signal path. So I replaced it with this nice film cap. It'll last forever. Our grandchildren can worry about replacing it. That sort of thing. I'm a strong proponent of trying to replace electrolytics with film caps when they're in the signal path. And I know there are different opinions on that, but that's mine. While I'm at it, I wanted to show quickly how these power amp boards set up, because it's kind of sweet. It's held in by 2 screws, the whole subassembly is, which secure it to the bottom of the chassis. And you simply loosen them quarter turn or what have you, and then slide it. And it pops right out for easy access. Then you pull out these 2 screws, pull these clips off, and then you can pull the power transistors off. While I'm at it, I also wanted to show, I'd mentioned in a previous clip that I was going to try and use the sill pads instead of the thermal grease. And man, look how nice those look. So we'll know more about that shortly, because when I get it up and running, one of the things I'm going to do is I'm just going to take a look at the operation with the thermometer, infrared thermometer, and we'll know more then. But just wanted to show you guys those couple of quick things. And obviously, or maybe not obviously, but I should mention that I changed the capacitors on both boards. And see there, and there. Just trying to keep them matching. That's it for now. More later. We're back on my tiny bench with the Yamaha CA-600. I am hopeful this is the wrap-up video. Done a lot on this guy since she hit the bench. Just kind of wanted to talk through that quickly. Recall that the power cord was cut when she first came in. Of course, we replaced that. And the receptacle, auxiliary receptacles, one of them were wings. One of the wings was broken on one of those, so we replaced that. There's also a pigtail fuse between the main fuse and those receptacles, and that was totally removed and had been bypassed, so we replaced that. Fuses on the main power board, or excuse me, the main amp board, those were both gone as well, so we had to replace that. After we got all of that taken care of, we brought it up slowly on the variac with the dim bulb tester. Made sure our power rails were good. There's a plus 32 and a minus 32, and then a 50. Plus 32 and minus 32 are for the power amp. 50 is one form or another, largely for everything else. After we brought it up and those power rails were in good shape, we attempted to set the DC offset and the bias. Right channel was responsive and looked like it was going to be working fine. Left channel, it's just started blowing fuses. We did some troubleshooting and determined that we had a blown output transistor. This one right here, TR615. So I ordered an original pull from an eBay seller that I was familiar with, who has a really good reputation, so I wasn't worried about it being a fake, and I wanted to go with the original as much as possible. While I was waiting on that, I checked the caps on both amp boards, and ESR seemed fine. However, the values were a little high. Usually in my experience, that's an indication that something's about to happen. So rather than wait, I just went ahead and replaced 3 of the 4. I used Panasonic 105s. The one that I did not replace was this guy right here, E609. That was a bipolar, and it measured fine. The other 3 electrolytics, I swapped them on both boards, made sure they matched. Also, while I was waiting for that transistor to come, I diode checked all of the other transistors on particularly the broken board, but also I just checked them on the other board while I was at it just to make sure. And everything seemed to test fine. Everyone had 2 junctions, base to emitter, base to collector. And then while I was waiting, I cleaned all the pots and switches. I used D5 on the pots. Good old fader lube on the switches. Pretty standard stuff. The transistor came in that I'd been waiting on, tested it on the trusty transistor semiconductor tester. Then I installed it, brought the unit back up slowly, dim bulb tester and variac, and blew another fuse on the amp board. I static checked, by that I mean with no power, just ohmmeter, cap checker, all of the other components on that board, and nothing was apparently wrong. Everything seemed fine. And then, to be honest, I sort of chased my tail for a while, and based on a gut feeling and really just nothing to lose, I went ahead and pulled this transistor here, the driver that fed the power transistor that was short. Now, as I mentioned, I had diode checked it, and base to emitter was good, base to collector was good, 0.6, 0.7 volts in each instance. But I didn't check emitter to collector. In my experience, if a power transistor goes and it takes out the driver in front of it, the driver is usually an open or a short between the base and one of the other legs. So I just moved on, I guess, based on that experience. But anyway, I pulled that transistor and I checked it, and sure enough, on the DCA-75, it showed the two diode junctions that I'd been testing, but it also showed an open, in essence, between the collector and the emitter, because it just showed the transistor as being two diodes. So then what I did was I pulled the sister transistor, that's fun to say, out of the other board, and I put it in the channel that had the blown one to start with, just to make sure that I wasn't going to have cascading defects. And sure enough, it came up fine. Bias and DC offset were both adjustable, so I thought I was going to be in good shape. As I mentioned, I did order the replacement and just waited for that to come. When it arrived, I installed it, made sure there were no shorts, dim bulb tester, set the DC and bias in both channels, and they both seemed to be operating fine. Everything looked like it was going to be fine. And then I tried to run signal through the amp, and all I was getting on the output was this loud 60 cycle hum. And eventually, after spending too much time going down a couple of rabbit holes, I put a signal from an external preamp into the power amp section of this amp, because it does have a decoupling switch, so you can isolate the preamp from the power amp. And power amp played seemingly fine. That is with regard to one channel. The other channel was silent. I decided to track down that power amp problem before I went back to the 60 cycle problem. And lo and behold, as you would expect, it was the relay in the protection circuit. I cleaned the contacts with the Q-tip really gently, and good old Deox D100L in liquid form. This is the one with the injector on it, dropper, whatever you want to call it. Sometimes I use these dental cleaning devices too, but I was a little worried about too much metal on metal, so I just used a regular cotton Q-tip for the cleaning of that. And I thought everything was going to be fine because a bunch of corrosion did come off. You could see it on the end of the Q-tip, blackish colored residue. And but still, one side didn't want to play, so I had to delicately bend one of the relay arms to establish better contact. Eventually, with external preamp into the power amp, I had sound to both sides, so thought we're getting somewhere. And I turned back to the 60 cycle, and I turned to signal tracing basically, and I think there are really three different ways you can signal trace. One, you can start at the beginning where you know you've got a good signal, and then just step through until you get to the point where you got a bad signal, and then you've isolated between the good and the bad, and you know your problem is most likely in there somewhere. Second method, of course, is you can start at the end where you've got nothing and then just go back a step at a time until you can find signal. And again, when you find it, you've isolated the problems between the good and the bad. And then there's a third method, and this is the way I was trained, and I still like to do it today. You take the complete circuit, from beginning to the end, and you just kind of divide it in half. And so you're saying, okay, I know I'm good here, and I'm bad here. What do I have in the middle? If I'm good, then I can go forward and divide this in half, and just continue to do that until you isolate it again. In my case, I started when it was pretty close to the middle. What you find in this particular amp, there are really 4 boards, 5 boards before we get to the preamp or the power amp section. There's this rear panel board where your RCA connectors are. That feeds the function board, which then feeds the volume, filter, and onto the tone board. So I realized I had 2 boards on this side, 3 on this side. There is no exact middle point. But I also realized that this connector here, coming out of the function board, was very accessible. It's 4 pins. One's your B+, and then you've got left output, right output, and just a ground, or as they like to call it, earth. So this was easy to check, and I noticed right away I didn't have any good signal here. So I went to where the signal was coming in, and I checked there, and I didn't have anything there either. So obviously the problem had to be here in this rear panel board, which I took apart, and sure enough, I found there was a trace on the board itself that had been just trashed, and it was just flopping in the breeze, like almost like somebody peeled tape off, and it was just dangling there. So visual inspection showed that. Pretty obvious that needed to be repaired before I did anything else. So I thought about doing a bodge wire, but I was a little worried that, you know, this amp will probably be transported a couple of times between now and when it reaches its final home, and I really didn't want that wire to have a chance to run loose. So instead I used a copper foil tape, and green mask with a UV lamp. But the smallest foil tape I had was about 1/8 of an inch. So I had to cut that in half and then put it in place and just make sure that it wasn't touching either of the adjacent traces. And then, like I said, put the green mask over it, which was close to the original circuit board color. Frankly, I used a little more of this than I should have, but I think that'll help hold that trace in place, the copper foil trace, that is. So after I had the trace in place, using a little UV lamp to cure the mask, let it dry and just sit for a little while. Did another visual inspection of the rear panel board. It seemed to be in order. So I reassembled everything, and voila, it worked. Unit pass signaled just fine. So I put it on full power, not through the dim bulb. Made sure I was dialed up to 120. I used the Variac. I always try and do exactly 120. I know some places are a little higher than that, but I use 120 as my standard because that's what it largely is here where I live. And I think that's what most of these amps that were built later in the 70s are accustomed to. And on that, I adjusted the DC offset and the bias on both channels, and tested it again. Sounded great, played great. Both channels were loud and proud. So I buttoned it up and hooked it up to do the final measurements, which I'll show on the next video clip. More in a moment. We are back with the Yamaha CA-600, and we're checking the left channel. Let's see what kind of power she can generate before clipping occurs. Pretty good signal, pretty good. Right there. So what is that? 19.5, I'm calling it. We say 19.5 squared is 380.25 into 8 ohms gives us 47 watts. This amp is rated for 40 watts into 8 ohms, so we're certainly achieving that. Let's take a look at our full power distortion. And our full power distortion is supposed to come in at 0.1. Full power, rated power, would be 17.88 volts. So we're watching here, dial up for 17.88. I don't like to spend too much time on this. Just 17.9, 17.7, 17.9, and our total harmonic distortion well below 1%. You can see the fundamental. You can see how nicely it drops off. Sorry for the camera. My gimbal's on the fritz. Be right back. We'll do the same test with the right channel. We're back with the Yamaha CA-600, taking a look at the numbers on the right channel. Let's see where clipping occurs. It looks like, oh, too much. Right about there, so 20 volts. 20, I think that's going to be 50 watts, isn't it? 20 squared is 400, divided by 8 equals 50 watts. So she's making 50 watts before noticeable clipping. Now let's run it up to rated power and see what our distortion looks like. So we're looking for 17.88. Once again, here's RMS. Whoa. Oh. The auto ranging of the meter threw me off for a second. 17.88, a little much. Come on down. Touch more. Come on down. Always good to go a little over rather than a little under. 17.89, and our distortion is 0.081. You see we've got a reasonable drop off from the first to the second, somewhere between 60 and 70 dB. So again, well within spec. Sorry for this handheld. More later. Back with the Yamaha CA-600, playing some royalty-free music, the handheld camera,